here we have the dependency test, which very much follows the same rules as the last one that we just looked at. So here we've got participants 1 through 6, their pre-training jump height, and then we've got the post-training jump height here, and then the difference of both results here. Then we've got the difference squared. So here difference is 3, square that, it's 9, 3 times 3 is 9. And then again you've got the equation up here, and then we filled in the equation. We're going through it step by step, simplifying it, making it a lot easier, just going through all the steps. And then eventually we get t equal the t value as 3.2. So here we've got 6 minus 1, which is 5, because 6 down here, the number of participants is 6. And then our calculated t value, which is here, which is 3.2, the critical value, which is 2.571. And then if the calculated value is less than the critical value, there is not a significant difference. And as the calculated value is bigger than the critical value, that means that there is a significant difference, and it's this one here. You can see it's circled, although it might be hard to see, because that's df here is 5, which is our value up here. And then you go along to 0.5, because that's the percentage that we're looking at, as in 5% right here. And then if you line those two up, it is here, which is 2.571. Then next up we've got the Pearson's correlation, and again going through it all, we've got participants 1 through 8, so you've got 8 there, sit and reach in centimeters, which is here, and then you square it, which is there. This is like all of the centimeters added up, and then centimeters squared here. And then just going through it step by step again, you've got the main equation here, which is filled out here. And then step by step, eventually the R value is 0.031. And then going across here, we've got 8 participants in total, which is n, and then you take away 2, so that's 6. So you go down here, you see 6, and then you go to 0.5. I think it's the one that we're working off, so 0.7067, which is here. Yeah, that is the one we're working off. And then if calculated value is greater than critical value, there is a significant relationship or correlation. So here we can see that our calculated R value isn't greater than the critical value, therefore there isn't a significant result here. And then finally we've got the Spearman's rank test. So here what you do is the number of players, so that's 10, and then you square it, so that's 100, and then points scored in the season. Then that's ranked 10, because that's the least amount of scored. 9, 5, 7, 6, 5. Is that 5 there? Sorry, I really can't see. It's 5, 4, 3, 2, 1. I think this one's been scribbled out a little bit. That's probably, I believe that's 8. 10, yeah, that should be 8 there. Points scored in the 2015 season. So you got 10, 9, 8, 7, 5, 6, 4, 3, 1, 2. So the difference in these 0, it goes up. It goes down. Actually no, it does go up a rank. As in, it goes lower, so it goes up a rank. Goes from rank 6 to rank 5. So that's a positive increase. Then here you see you've got a negative one, goes from rank 5 to rank 6, which is not what you really want. It's kind of going backwards, so that's marked as a negative here. And then 0, 0, same as here, and then you got the values there. You write it down as before, and then you just work through it. Then the R value is 0.976, and then again df equals your number of participants, which is 10, minus 2, which is 8. Calculated R value 0.976. Calculated value, so you go to 8 here, you go across, and it's 0.74, which you've got noted here. If calculated value, I can't see that one, I believe it is greater than critical value, there is a significance, and because it is greater than, then that shows that there is a significant result. after this experiment. And that is the end of the slideshow. Thank you very much for watching.